Hello, everybody. Before I introduce Tim, I'd like to say one of the directors this year wants to be treasurer next year, so shameless plug alert. So our presenter today is Tim Burkhardt. He is a multimodal planner and project manager at HDR in Minneapolis. You couldn't tell by looking at him, but he has over 25 years of experience. He spent over a decade working in Portland, Oregon, and is currently obsessed with autonomous vehicles. So, if you could all welcome Tim for me.
All right, thanks, Mark, and thank you all for having me today. I'm glad to share what I know or what I don't know about this topic. And I knew before coming here this would be a smart group, which was borne out in the polling. I now know it's also an opinionated group. And I welcome your questions, and I'm not sure I'll have answers, but I'll do my best. In terms of where I sit, I don't have a year in mind, but I tend to be more optimistic. But in terms of this presentation, I do try to ground it in both sort of what's empirical that we know today and also, as you'll see, what we can do today in this interim. In terms of, and many of you were at the ITS Minnesota conference last week and saw many presentations on this topic and are steeped in this. And so there's lots of analogies about how quickly technology is moving today, which I think is something that's different related to autonomous and connected vehicles. And I think we all, as kids, we were told to never get into a stranger's vehicle, right? And growing up, maybe it wasn't that long ago, you were never supposed to meet up with somebody that you've met on the internet. But now we're supposed to use the internet to ask strangers to come to our house so we can get in their cars. So just think about that. Things change. The challenge in terms of what we do as planners and engineers every day, obviously we're used to thinking ahead and trying to predict the future with our plans, whatever it is that we call them. But as my little catchphrase says, and we all know from reading the paper, Elon Musk and others are not waiting for the next CIP or the next comp plan update or whatever it is. Things are moving quickly. So how do we, realizing that in the course of that 20 years that we've already looked ahead, things are going to change and we need to act, today and tomorrow. The promise, I think we're all sort of steeped in, but I like this summary, the idea of transportation as a service, that rather than the way it is now, we'll have an app or the equivalent, and we can really call up whatever the best mode is to get us, to move us or to move goods, and then that will achieve all these things up here. It'll be cheap, it'll be equitable, it'll be accessible to everyone, et cetera, et cetera. That's the promise. And the longer list here is, scenario one is utopia. All the things that we want to come true about autonomous and connected vehicles come true, and the world is a better place, and there's no downsides. And then you can guess what's coming on the right-hand side is, the opposite. And I think we're both, and I can tell everyone has thought about this topic. You kind of go back and forth between, yeah, that's going to happen, no, that's not going to happen. So without reading through all these are all kind of issues that we're dealing with as we think about, can this both achieve its goals, and if it's going to, when is that going to be, and how do we make sure that we get the positives? And yes, I did put the signal images on there just for this crowd today. I thought you might enjoy those. So this is one of many graphs of predictions of the question we just talked about. When do we see the fleet changing over to autonomous vehicles, and at what level of autonomy? And key questions there, how fast will that occur? And there's predictions on, well, if we have gradual transition, what's that point when we've got enough vehicles that have turned over, the fleet has turned over, that we actually realize the benefits? It's certainly over half by some predictions. But then the more, maybe not interesting, but challenging part is, well, what about in between? What do we do during that transition with all our systems? This graphic I like. It's more about us as consumers and what will motivate us to change behavior, because certainly on the negative list is like, I like my car, I want to drive, it's not convenient, et cetera, et cetera. So that, the bottom right there, the lower cost, at least by this analysis, says if some of the economic predictions come true, and it is a lot cheaper to purchase a share in a fleet car via your app rather than own one, and it's more accessible and it works for more trips and more people at a lower cost, that will motivate us. That does motivate us. Someone else in the group was also onto this. We're really focused on cars here, but if we're thinking transformational technologies, maybe cars aren't the answer as much as we think they are. And you can put $10,000 down right now on a flying car if you'd like. And the burrito illustration was in Australia, but that's use your app to call up the food delivery and it comes to you by drone. So I like to think about traffic jams in the sky. I mean, there's a whole other level of transportation planning and design that could happen. But really the point is, this is fun to think about, and some of this will hold true and some things will probably be completely different, by 2050. So my attempt to explain some bases of the technology, which a lot of you probably already know. I really like this graphic. Again, if you follow this at all, there's always either a new company or some permutation on the existing businesses. So you see all these connections, the different, first merging of industries, right? It's the automakers, it's the tech companies, it's the hardware, software, the data, et cetera, and all investing in each other, partnerships, acquisitions. And it's really interesting to think in 5, 10 or more years, which of these companies are going to be on top? Is it, Ford and GM? Is it Apple? Is it Amazon? Is it something completely different? But clearly, a lot of these will not still be around in their current form. The merging of industries is interesting, too, because all the comparisons to, well, what happened when we transitioned from horses to vehicles? Well, there was a merging of the carriage and the new gas engine, two separate things that came together and created a whole new industry. The brief summary of autonomous versus connected, which is fairly obvious, but that top image there, the Google or the Waymo vehicle, I rode in that this summer, and I asked the driver or the non-driver if the car was connected to anything, if they were looking at that type of technology. And the short answer is no, at least in terms of a dedicated, DSRC, that type of connection. So point is, there's one school of thought that says this vehicle is going to drive itself. It's going to use existing infrastructure. It's going to be connected to, the cloud, which is a type of connectivity. But then the more classic connected vehicle is that image below, where the vehicles can talk to each other, they can talk to the infrastructure. Ultimately, it's sort of obvious it makes sense to bring the best of those together, but certainly there are two different ways of thinking about it. I think the idea of redundancy is most striking to me is that we all worry about, well, what happens if blank, whatever system goes down in that autonomous vehicle? And having the autonomous and connected provides that redundancy. If you're in a GPS tunnel and you're relying on the map, well, you've got sensors or you've got some other type of connectivity. And then this image again just shows the different pieces. At the core is the vehicle. You've got some type of computer and all the sensors. I think it's interesting to think, people will say, well, from a safety standpoint, humans, we're trying to eliminate the thousands of fatalities, but we're actually pretty good machines. So what we're trying to do right now in the autonomous world is to recreate all our senses. It's these different sensors for seeing, hearing, and et cetera. So in some ways, those are still progressing and are not at the human level. On the other hand, the reaction times, et cetera, are much quicker. So, you see this long list of sensors. Maybe we merge those together over time as new technologies develop. And then you also see the connectivity, so connecting the car outward via cellular or via DSRC, which is this sort of emerging wavelength that is for now dedicated to autonomous vehicles. Artificial intelligence also is everywhere today in terms of all the different technologies, whether it's Siri and Alexa and all kinds of stuff. It really is sort of the leading edge in terms of that vehicle being able to deal with the more difficult situations. This idea of deep learning subset of artificial intelligence where the car, learns by millions and millions and millions of repetitions and variations on those repetitions. And then all the models that you see now where Google or the others are testing their vehicles, what the data they're collecting, and they go back and they make tiny adjustments to the software for these different sort of edge case situations. So again, artificial intelligence, that's about all I know about it, but the advances in that are one of the things that will enable us to kind of narrow the gap on where we are today and where we would like to be with autonomous vehicles. The mapping part of it, I think, is fascinating. I wasn't so aware of it at first, but in the best cases, these vehicles are driving in places that have been mapped already and have this real-time map that both guides the vehicle, but then as these images show, and these are from Here, which is a mapping company that I'm not necessarily promoting, except they sort of capture the idea of the vehicle learning from its environment, sharing that information. And so it really, that is a type of connectivity that you get, not from the vehicle connecting directly with the infrastructure, but indirectly by connecting with the network of all the vehicles on the road. So the real life examples, most of which we all are aware of, but part of the idea is this is happening. It may not be happening here in Minneapolis, but you can, ride in a self-driving vehicle. It's still got a human in there, but they're not piloting the vehicle. The center photo is Volvo in Sweden. They have families that have signed up to have all their family transportation provided by the autonomous vehicle. And so putting it to real use, not just a trip to and from the airport. And then in the upper right is Waymo, former Google in Arizona, similar type of pilot, just to get more and more miles and more situations. So that was passenger vehicles, and then in the transit area, really what's out there is all these small shuttles, 10 to 12 passenger shuttles, and there's several different manufacturers on the scene with a similar type of product, so it's not quite the usual bus that we think of with transit. That image in the lower left from Daimler is not available yet, but they're not the only one working on a full-size passenger bus. So these are in use, the shuttles in pilots, but also in real urban environments, the Las Vegas Strip. There are cities in Europe that are using them really for transportation. And then I have on here the MnDOT project that some of you know of it or are involved in testing the Easy Mile shuttle, which is the one in the lower right, during winter driving conditions this year in Minnesota, and then having a little pilot project during the Super Bowl. And someone mentioned trucks, which by some is considered to be the low-hanging fruit for really getting to full autonomy. And these different images show different applications, from the platooning, which saves fuel, if nothing else, and adds up significantly. And so there's a lot of interest from the trucking industry in doing that to cut their costs. And some people may have seen the first fully autonomous beer delivery down I-25 in Colorado early this year, done by Otto, the Uber self-driving truck company. Closer to home, or your home, the garbage truck up there in the upper left was an example from Sweden. But typically, if you think about it, the garbage truck goes down the street, there's two people. There's one operating it and one getting in and out. This has no operator, or it's autonomous, or it's controlled by the person on the street. So labor costs just went down. And then maybe a little easier to see in the lower, well, I guess center and bottom picture is just at a port where there's all these trucks that are just sitting there. The drivers sit there for long periods of time getting through the lines. Pretty easy to automate that, and the drivers can go do something else. So as the headline says, and we all have these questions, the world out there isn't perfect, and these are some of the issues that are somewhat obvious, but are those edge cases that are not common but important that are still being worked on. Everything from the fact that we are all unpredictable, and these machines need to predict that and deal with that. There are some cases where the sensors get fooled. They can't quite make out like a large puddle. Is that a puddle? Is it ice? A pothole sometimes in the light. Like, we can figure out which ones to drive through and which ones not to. And then the one at the bottom that everybody loves is that machine has to make a moral choice. We envision that. And do you save the driver or do you take out the group on the side of the road? And the column here about solutions, I don't know if those are solutions. A lot of those are advances in technology. And the bottom one, I think it's more a change, if this is going to happen, in how we respond to the case where the machine kills somebody. And fatality today, it's tragic, and we have our feelings about the driver. Even if the driver was totally at fault, we have some forgiveness because it's a person, and our level of forgiveness for a machine is different, and that's going to be a whole new thing. I assume we're going to get there, but what that looks like, I don't know. Quickly, when we go back to that first slide of, how do you think about all the benefits and the different types of technologies? We've got the connectivity, we've got autonomous, we've got the idea of the vehicle being shared, that is more than one passenger, and then electric, which I didn't talk too much about, but a lot of people imagine a fleet of electric vehicles in the future. The bright green there sort of says how these different technologies perform against benefits of safety, congestion, emissions, land use, mobility. And this came from a recent TRB report. What I thought was interesting is to step back and realize not one of these addresses all those issues the best. If you squeeze them all together, you basically do have everything covered except not so much land use, which is not really a function of the vehicle. So just to point out, again, none of these solves all issues by itself, and there's a lot of complicating factors. So on to my version of what do we do, whether it's between now and 2022 or between now and 2050. I think that was the farthest out we got, or farther. The first thing I would say is it's already happening, and we're already doing it, albeit on a smaller scale. So we talked about Teslas, and that's a photo from inside a Tesla that I wrote in earlier this year, and you can't see, but it's got the lane keeping assistance going. So there's more and more of those level 2, level 3s, or partly autonomous vehicles out there, mixed in with the rest of us driving down the road. Not to say it's all perfect, but that is happening. Similar with the more true self-driving vehicles that Waymo, Google, Uber, those are also being tested in cities around the country and around the world. Again, mixed in, not on test tracks, they're out there with existing traffic. And then the other thing we're doing now is we are already reworking curb space to deal with all the pickups and drop-offs that we're getting from ride sharing, which is today's version of the self-driving fleet tomorrow, particularly at airports and in some of the larger cities where there's an incredible density of ride-sharing vehicles. And then on the emerging side, in terms of this transition, is policies. I'm not aware of any yet, but certainly San Francisco and other cities are looking at that as they realize how much congestion they're getting from ride-sharing and all the trips that is adding to their system. So we can envision a time not too distant in the future when we do start to try to enact policies to manage some of the negative impacts of the eventual self-driving vehicle. Back in that table of the things being worked on, the idea that these cars will follow the rules, it may be to a fault. If everyone's going 70 and all the self-driving vehicles are going 55, that could be a problem. And so this is one of those edge cases that I think we will get there. I don't know what the answer is, but artificial intelligence is part of it. The vehicle needs to learn to know the difference between, how do you know when to break the rules? And then the pilot there at the bottom that I already mentioned is, I put it on this slide just because it's one of those things we think, well, this is all great in Arizona, but what about Minnesota? And we probably don't have all the answers to snow and ice yet. Again, I think we'll get there. So this has number 12 on it because I started with a top 10 list to count down the things that we could do, and I got to 12 and then I stopped, so I'll try to get through these and then I'll be done. So number 12 for things for us as engineers and planners, know your context. The idea being, again, well, we don't have all the action here right now. It may not seem quite as attainable here in our location or with our client or with your agency. So realizing there's the early adopters, there's the late adopters, and there's the maybe not gonna adopt. And where we're working is going to make a difference as to what kind of solutions are appropriate right now, and that will change. But we're not all, the Bay Area, for example. Number 11, and I like this as a planner, but we're all kind of planners, is the idea of scenario planning, planning for uncertain futures or multiple futures. It's a little bit simplistic, but the green line is, say, how we do traffic forecasting. We either use a constant projection, or at least we have a point out there in the future, and we just kind of go with that. Moving over to the right, the idea that there are actually multiple potential futures out there. We don't know where we're going to end up, but we can think about multiple futures. And within each one of those, it's probably not a line. It's probably more like this cone shape of there's some uncertainty around that. And these images come from a tool that HDR has developed called TransFuture, which is a scenario planning tool for exactly this purpose. It uses a lot of complex statistics to analyze sort of the inputs, the trends, and then come out with results. So then the lower left is if you take those different areas of uncertainty and in this case statistically composite them, you have the idea of this composite uncertainty cone. And then the real point is in the lower right. You probably can't see the words, but there's a range of possible futures. There's some that are more plausible, and the most probable in the middle. Again, we don't know that just because we used a tool like this, but we can use those inputs to try to get to something that's more than just a scratching of the head. And perhaps most valuable with scenario planning is you can change your inputs and do some sensitivity testing to say, well, what if the adoption rate for autonomous vehicles is a lot slower, a lot faster? Or what if some of the other things that we think will or won't happen do or don't happen? So that's scenario planning. Next one, design flexibly. Probably easier said than done, but I think the first thing that is hard to challenge is the idea that we will need more pavement as a result of the changing of technologies than we do today. That may not always be true, because I'll talk about more trips that will be generated. But the idea of don't overbuild, being a little bit more, even more cautious about why we're going to make a major investment in particular. And certainly on the highways is where we see the most potential for, because the vehicles, as we get to that adoption rate, whether we have a single lane of autonomous vehicles, ultimately multiple lanes that they can travel more closely together, following distance and side to side. The image here is this idea of future-proofing, of how can we envision the same, in this case, the same pavement with the same footprint, but imagine it being programmed more flexibly in the future. And the technology isn't there yet, but I love to imagine, this will be good for all you signing and signal people, that there's nothing painted on there, that it's all electronic, that the lane markings, the speed limits, everything you need, the directions, it's all electronic. If you could manage that dynamically and electronically, you could make a lot better use out of that pavement. So if anyone wants to invent that technology and get us there faster, I think that'd be great. But again, that's maybe further along, but it gets you thinking about that idea of, well, that pavement is a resource, but how we use it may change. A little thought experiment here, and this comes from the University of Florida, or Florida State, I'm sorry, and the Florida DOT. So on the left, a typical 5-lane arterial today, and envisioning how that might go through a couple changes to an ultimate autonomous future. So the image on the right shows that we've narrowed the stripe surface at least a little bit, and we've got one lane in each direction for traditional vehicles and one for autonomous. Again, I don't have all the details of how that might work, but that's certainly an idea of a transition. We've got dedicated space. And then the ultimate vision, which this goes back to our predictions, it says after 2060, it might be sooner than that, but imagine the all-autonomous roadway. We've got same number of lanes minus the center turn lane, so 2 lanes each direction, but they're narrower. We've carved out more space on the edges for bicycle and pedestrian space. And one of my favorite things about the image, if you can see the pedestrians walking, they are not paying attention at all. And the idea that they don't have to, because the vehicles will look out for them. And then you may notice that the signals went away too. They may not work everywhere, but in theory, the vehicles can navigate without signals, even from all directions. And then on the right, you can see in the bottom right that we've got the brown, it says drop-off lane, has replaced your on-street parking. If in an urban area, you're not going to necessarily need to park as many cars right there, but there's going to be lots of pickup and drop-off activity. And you can see how the pavement has changed. There's no signal there anymore. And if you look at the back of those two images on the upper right, you see a parking lot that's been replaced in the lower right with a building. Again, the idea you have to store those autonomous vehicles somewhere, but you have more flexibility. It's not going to have to be right there in your downtown core. The next one, design for machines instead of humans. And so the top, just enforcing the idea that most of these devices we envision now, sort of the smart city devices, require communications and power, fiber likely for communications, though some is going to be wireless. Some power might be solar. But that's sort of the minimum ask right now is if we want to have a connected infrastructure, we need those two things underground. And then above ground, and somebody pointed this out, machine readable signs, paint, things that can enhance the experience of that connected vehicle, autonomous vehicle. Right now the images, they do focus on the speed limit sign, they can read those. But to make them more visible in weather conditions, further visible further ahead, I have a little graphic from 3M because they're one of the companies that is working on exactly those types of materials. Number 8, anticipate new policies, and I hinted at this a little bit, but the idea that we may have policies to control congestion, to control where we do or don't want autonomous vehicles, and those can certainly mitigate some of the things we worry about. And then we may also have places you can and can't drive autonomous vehicles. Dedicated lane, for example, or you might say in a rural area where we don't have maps, we don't have good infrastructure, we might want to prohibit autonomous vehicles until such a time as they can handle that type of environment. Number 7, expect more trips, particularly in urban areas. Again, I don't have the crystal ball, but that's what we're seeing so far. And there's some logic to it. If you and I can have the car do whatever we want, whenever we want it, like why not send it to go do an errand while you're at work? Some of the predictions are at least 50% increase in trips in urban areas, maybe more. Kind of a nightmare. So again, we could work policies to control that, which has its own downsides. But think about more trips in those urban areas. And generators, I'm thinking about autonomous vehicles. Right now, certainly we see, the delivery of everything, which in some cases is replacing the delivery trip with, or our own personal trip with a delivery trip, but it's causing us to get a lot more things delivered. This little bot in the lower right, you may have seen, can bring your lunch if you're in DC. It was in San Francisco, but speaking of policies, they outlawed it because it was too much of a hassle on the sidewalks. Number 6, well, this is taking a long time. Expect more efficiency, and we kind of covered this too, the idea that especially on a freeway, you can get more vehicles in the lane. And I do love this, the graphic on the lower right, that dashed line is just showing the capacity of a 6-lane roadway, which normally should just be a straight line because that doesn't change. But if you anticipate the vehicle fleet changing over to autonomous, also you can get more vehicles in that same space, which is a very powerful concept in terms of the things that we spend the most money on, the really large investments. Number 5, don't wait for safety. Safety obviously is a major motivator for both the public and private sector and the whole endeavor of autonomous vehicles. And this gets sort of the autonomous versus automated. The safety features that are in a lot of new cars right now, whether it's the blind spot indicators or the lane keeping or the forward collision, those do have significant safety benefits and they're available right now. So I think that incredible reduction in fatalities from autonomous vehicles is the sort of a holy grail that's motivating a lot of us not to overlook that as the vehicles just progress, there's safety benefits that are coming along the way. And that bottom note was really what I already got into, how we deal with the crash, the fatality that's caused by a machine. Number 4, I said promote understanding, which is I think what a lot of us do already in the projects that we do, realizing as we are, whether we're the agencies or we're the consultants, that this is a new technology and like other new things that we've dealt with. And I was thinking about the roundabout. That was, at least in my career, like this crazy idea, 10 or 20 years ago. People hated it. They thought it wouldn't work. In some cases, it didn't work. So our job to be objective, to help explain, and ultimately to build consensus around whatever it is. And so we sort of are on the front lines of helping translate that technical information and also validate that we're on the right path. The image on the lower right is an example of the front frame of a video that HDR produced for the Iowa DOT, which is about an 8-minute video, kind of soup to nuts on autonomously connected vehicles and that agency's vision. But it really was oriented towards preparing the public in Iowa for changes in that direction. Number 3, all about the data. I was talking to somebody about this as well. It's already everywhere. A lot of you are in it a lot more than I am. But on the infrastructure side, just transmitting and storing the data, it's been explained to me that we have nowhere near the capacity right now if we really had every vehicle out there, connected to each other, connected to the cloud, connected to the infrastructure. It's incredible amounts. And again, I have faith that we will get there. And I've seen some examples of newer technologies to just be able to transmit and use all that data. Then understanding the value of that information, more and more data is money, data is gold, and the idea that we in the public sector will possess more and more of it. We have to know how to use it for our transportation purposes, but also recognize when it has value and protect that, hopefully capture that if it's of interest, if we can sell it. And then the point about workforce, the idea of the data scientist. You can get master's degrees in data science now. It's lots of job openings for people that can sort of do all of this. And probably a lot of us either don't have that skill or our agencies may end up needing more of that type of skill. A little bit of a continuation from that, advocate for public benefits. If we look at the utopia, dystopia slide, there's concerns that this is being driven by these private interests and they won't have the broader public interest in mind. May or may not be the case. So social equity, certainly trying to maintain access and really realize those access benefits for people with disabilities, for elderly, for children. And then cost as well. A lot of the momentum for this, as you know, is that this fleet of autonomous vehicles will be cheap. But will it? And how does that end up happening? And who gets access and who is it cheap for? And then just geography, as always. Is this just in the cities? Is it in other places? And how can we help make sure that the benefits are truly passed on? Use of public space, again, sort of like the data, the public right-of-way that's used for all the data transmission, for the fiber example. There's a public and private coming together and make sure that on the public side we're getting the proper exchange of value for that space. And then the safety algorithms, which I've talked about already. I have the Smart Columbus, which was Columbus was the winner of the Smart Cities Challenge, as people know. And that was really based on a social equity idea, was sort of the idea there of using transportation to improve access and equity. And then last one, had to put this in here as a planner, revisiting our plans more often. But the point is, whether we call something a long-range plan, the words there, that we make a plan based, we sort of think we know what's going to happen in the future, and here's how we're going to get there. That's our typical plan. Versus a strategic plan, which says we don't really know what's going to happen. What's the atmosphere is dynamic, it's changing, the environment is dynamic and changing. And so that strategic plan is shorter and it's focused more on those external factors and how we react to them. So that's my planning 2 cents, is just we need to be a little bit more proactive than we already are. So that's my list and that's my presentation, and appreciate your attention and glad for any questions. Sir.
I guess I'll start off questions, Tim. Was the 2040 plans kind of being what we're using the plan for the future now? what are some of the improvements that you see that we should, as traffic engineers, put into some of these plans?
I wish I had a short answer to that question. I think some of the ideas are in here, but I mean, the transportation plan somewhat depends on what is our forecast for demand, and then what modes are we going to use to meet that demand. So I think, I guess I've already said it, I don't have the answer, but just,
And the most
I mean, not maybe just fixating on that number if it's the forecast of demand. I think we know that, but we still use those numbers. We generate those like, okay, that's the thing. And we know those aren't always, that isn't always where we end up anyway. So I think that flexibility, that would be my main thing. So yeah, I don't have the answer. I mean, the other idea is like, well, what type of mode split or it's kind of modes are getting blurred together as we think about shared mobility too. So what type of vehicles and what is their capacity going to be, such that what is our footprint? And again, radically different answers. I mean, those of you familiar with the I-94 projections that MnDOT has done in terms of trips in that corridor, if it's in an autonomous future, that's somewhere those numbers come from. It's staggering. So that's one answer. You know, on the other hand, work that HDR did for Iowa DOT on the rural parts of I-80 is where that graph came from, where we showed you don't need to widen this road to 8 lanes, probably never, or certainly not when you thought you did. So I'm just repeating myself, but that's a good question. Others?
Going back to YouTube videos, there's one that always shows up for an intersection where all the vehicles are just kind of arriving on their own and meshing their way through. It's still more, and on the other hand, we talk about truck platooning. It's actually still more capacity at an intersection if we platoon the arriving vehicles, because they do have lengths. So that,
If we platoon them?
yeah. So organizing the flow before you get to the intersection makes more sense when you get close to capacity. Middle of the day, yeah, or overnight, fine. That's one of those YouTube videos that I always gag when I see it.
But so does platooning mean no signal, or does it mean a different kind of signal that?
Grouping the cars approaching an intersection with platoons. It's what coordination does now, in theory.
Yeah. But are you going to stop them? I guess that's what I was wondering. Yeah. Other questions? Yeah.
Tim, what's the role of our profession moving forward? As you point out, a lot of these tech companies are just flying ahead with whether we're on board or not. So how is our profession as traffic engineers and planners going to evolve?
It's probably my opinion. I mean, and you can tell a little bit where I'm coming from. I think embracing it and embracing even those entities and trying to partner with them. I think we know, Lyft and Uber hold their data very closely so far. Some of that's starting to come out. The thing that always strikes me, though, and maybe it's because I'm a planner used to like nothing happening except plans, but this is just happening so quickly. It's not like our typical, public sector mentality. We're going to make a plan and this thing's going to happen over many years. This is a different timeline. So I think just understanding that whether it's 2022 or 2050, it's just happening quickly. And so I think connecting with it that'd be my one thought that I think.
I'm just going to make one general comment just around, because I've heard this a lot from people, is the biggest thing that people are saying to kind of get ready for the future, make sure you're signing and striping. And that's basically with all your public agencies, make sure you're signing and striping because that's what vehicles are using. There's actually companies going out right now on our roads and collecting where our signs are and what the signs are saying so they can map it for these companies. They can't read the signs, or if we change our signs, we come up with these weird messages on our signs that nobody can understand what the hell it means. That's the one thing that we just need to be careful about. And I think that's where starting to think on the federal level is the NCITE. And we have all these signs that we say, well, it's not an NCITE, you're supposed to make one. It's going to be kind of to the point where we stop making weird signs and we just stick with what's in NCITE because that's what the cars understand. And to make your own sign, to try to guess what the people are thinking in their own mind, it doesn't matter anymore because the vehicle's making all the choices. So signing and striping is pretty much the number one thing.
All right, thank you.
Okay, I have you come up for one more second. We have a small gift for you, and we try to be original, so here's your very own NCITE pint glass. Thank you.
Thank you. Thank you.
We have one final item on the agenda. John Davis is here from, he's our Midwest District Representative to the International Board, and he has a very special announcement and presentation to make.
All right, if I could have the students from Minnesota that won this plaque. Come forward. For those of you that may not be aware, annually the Midwestern District and ITE have a competition among student chapters called the Traffic Bowl. Each district in ITE and at least Canada and the United States, those districts, have a competition to select their representative to the International Grand Championship that is held at the International Annual Meeting of the Institute. So for the second straight year in a row, the University of Minnesota student chapter has been victorious. Now these students do not take the easy route to get to their championship. Because we have 9 spots available typically. We seed the teams, and the top 6 seeds get into the first 2 games. The 7th and 8th seed, or maybe the 7th seed, is in the 3rd game, and then the team that does not win one of the first 2 games, but has the highest score, they get to play again in the 3rd game. This is how the University of Minnesota has done it each of the last 2 years. They must need a warm-up like this. But in any case, they did very well, and this is their congratulatory prize. So, this isn't your whole team, so can you introduce yourselves and then someone say who's missing?
All right. I'm Josh Carr. I'm the Vice President of ITSL this year. I'll be transitioning to President actually probably next semester. And I'm a senior studying civil engineering.
I'm Kristen Carlson. I was the president of ITSL last year, and I was on the competing team. And Jackie Nowak was also on the competing team, but she's not here today.
I'm Ben Allbauer. No, Sarah I was on the team. Kristen and I were on the team the last few years.
Let's give them another round of applause. Just as you're gonna have pictures.
Yeah, we'll do pictures after the meeting, so stick around.
But just a couple words, if I could, to promote as you heard Steve Burkhardt say, the 2018 international meeting will be here in Minneapolis. That also includes the Midwestern District meeting as well as the Great Lakes District meeting. So our district meeting is a joint meeting with international. We're looking to have 500 people from the Midwestern District here. Don't worry, I told the Missouri Valley section they have to have 300. They're the largest section, they encompass 6 states. I'm sure they can get at least 50 people from Oklahoma to come up. Why wouldn't you come up to Minnesota if you're from Oklahoma? Well, there's also makes other questions there too. But anyhow, as Steve mentioned or was mentioned, the call for abstract is out. If you have ideas, please get them in. We anticipate it being a very competitive selection process. As for this last meeting in Toronto, which was a joint meeting with the Canadian district, we had almost 400 abstracts, and we don't have 400 speakers. But we hope to have very competitive, and I'm sure we'll have a very fine technical program because we have an excellent local arrangements committee from this section that will be here planning the meeting. So mark those dates down. It's in August of next year. Great Lakes District, Midwestern District, and the International Annual Meeting will be here. It's at the Minneapolis Hilton downtown. And we hope to have, I hope to see everyone here at least 1 or 2 days, or maybe 3 or 4 days at the meeting. And we will have the Collegiate Traffic Bowl will be on Monday afternoon for the district. The Grand Championship will be the following day in the afternoon on Tuesday. So we're looking forward to seeing potentially Minnesota win again, but I can tell you they will have some competition. The University of Arkansas is pledging that they're going to be coming up for the meeting. So there'll be a new entrant in the competition. But again, I'll have more information about things from ITE coming up when I join you for your annual meeting next month in November. So with that, thank you very much.
Thanks, John. Final comment, there's a few things that will happen after the meeting. So students and John, if you could circle back with Scott, we'll find a nice bright place to take a picture. Same with Tim, we'll take a nice picture in a bright spot of our speaker today. And then past presidents, you should confer as well. Thanks everyone, we're adjourned.